Hey everybody, Mike here. I'm looking at section 2.7, inequalities, and we want to start off by solving these simple inequalities. If I have x plus 8 is greater than 1, I'm going to solve by subtracting 8 from both sides. This is just how I would solve if I had an equality, an equation. I get that x is greater than negative 7. So on a number line, I would say here's negative 7, here's negative 8, here's negative 6. Here's x, bigger than negative 7, with a round parenthesis because it's not equal. About this one over here, x minus 10 is less than 3. Well, to solve this, we're going to add 10 to both sides. And when we do that, we'll get that x is less than 13. What's that going to look like on a number line? Well, here's my number line. 15, 14, 15. X is less than 13. Less than it. There's x. And note again that x is not equal to 13. What about multiplication? Say we have to solve 1/3 of x is greater than or equal to 4. To do that, we're going to do 3 times 1/3 to get just x. But we've got to do that to both sides. So we'll get that x has to be greater than or equal to 12. On a number line, 10, 11, 12, 13. I'm going to use a square bracket to indicate that x can equal 12. And it can be later. For this next one, we have negative 2x is less than 10. I'm going to take and I'm going to divide both sides of this by a negative 2. But when we do that, we've got to reverse the direction of this inequality. We get that x is greater than a negative 5. So on a number line, go over to negative 5 and say, hey, here's x greater than negative 5. But because this is a strict inequality, x can't be negative 5. More problems. Here's one. We're going to solve 8 minus 6x is greater than 2 minus 5x. Let's group our x's together, and this is very important. I'm going to do that by adding 6x to both sides and get a positive coefficient. I want a positive x because I don't want to have to worry about reversing the direction of my inequality. When we do that, we're going to have 8 is greater than 2 plus x. Back to both sides, and we'll get that 6 is greater than x. Cool. Next problem. 3 times the quantity 3 plus 4x minus 7 is greater than or equal to 98. Now we don't have to distribute this to solve it, but I know students like to distribute, so let's go ahead and distribute 9 plus 12x, and then that's going to be minus 7 is greater than or equal to 98. 9 plus 12x is greater than or equal to 105. 12x is greater than or equal to 105 minus we've got to figure out what 96 divided by 12 is. Hey, you know what? That's 8. So x is greater than or equal to 8. 8 is a solution. Now, what was I saying about not distributing? Well, what I'm going to do is I'm going to go ahead and I'm going to add 7 to both sides. We'll get 3 times the quantity, 3 plus 4x is greater than or equal to 105. And then we're going to divide by 3. See, because this is 3 times what's on the inside of the parentheses, these 3's will reduce out. And what we'll have is just 3 plus 4x. Meanwhile, over here, I've got 105, and I'm dividing that by 3. That gets me, let's see here, 3 goes into 10 3 times, 3 goes into 15 5 times, 35. Subtract 3 from both sides, so 4x is greater than or equal to 32, which means that x is greater than or equal to 8. We get the same solution. This method on the right, written in blue, is useful for things beyond addition and multiplication. If we've got square roots or quadratics or logs or something like that, we've got to do it this way. So it doesn't exactly hurt to practice it, but we can absolutely distribute if we feel like it. That's it for this video. I'll see you next time.